This particular example is designed to illustrate a point. The first thing we want to do is integrate from -2 to 2 of x cubed dx. So -2 to 2 x cubed dx. So that will be x to the 4 over 4 from -2 to 2. Using the top limit, that gives me 16 over 4, which is 4. -2 to the 4 is also 16. 16 over 4 is 4. So that gives us 0. Now let's look at this one. So we're integrating from -2 to 0, x cubed. So that's x to the 4 over 4 to be evaluated from -2 to 0. Using the top limit we get 0. Using the bottom limit we get 16 over 4, which is 4. So that is -4. And then finally we have the integral from 0 to 2 of x cubed dx, which is x to the 4 over 4, evaluated from 0 to 2. So top limit 16 over 4 is 4, bottom limit is 0, so that one gives us 4. Now what we're illustrating here is that the integral from -2 to 2 of x cubed dx is equal to the integral from -2 to 0 of x cubed dx added to the integral from 0 to 2 of x cubed dx. And we discussed that in more general terms earlier in this section of the course. What implication does that have for area? If we look at x cubed, it looks something like this. It's got a point of inflection at the origin. And so what we're doing here, or what we were attempting to do with this integral, was work out the total area trapped. The problem is that this area is below, and when you do that by integration it comes out signed as negative, and that's because if we think about those rectangles, they come down this way and the y values are negative. So if we actually want this area here, what we really need to do is ignore the sign on that one, and this one obviously is positive anyway, and that total area that I've shaded, whether I've shaded it red or blue, is actually 8 square units. And that's what we're trying to illustrate here. In this case we'd have noticed straight away there was something wrong because it came out to 0. But if you have another curve which just dips below here and comes up, and you wanted the total area, if you integrate all the way from here to here, this little bit of area gets cut off, whereas really you want it to be added on. Now either you'd have to find these points here and split your integral a to c, c to d and d to b, and then ignore any signs and add up like I did here. Or there's a trick you can use on the calculator, and that is as follows. So what we would do is do the integral from -2 to 2, and then just in here use the absolute value function, which is this one here, and then put in x cubed dx, and you should find the answer is 8. What the absolute value function is, it doesn't allow negatives, so it changes this function so that this part is reflected up here, and then the areas are all above